So it's going to be 2-4. This is going to be day 1. So again, more formulas. So remember, I had you guys print out your formula sheet. So we focused on our sum to difference already, and we focused on these co-functions. So those ones are here. Today, we're going to be working with the half angles. So they're all titled on here. So hopefully that will help you guys when you guys are working on stuff. I do want to note for the half angles. Oh, sorry, we're doing double angles today. Double angles. We're doing double angles today. Half angles, the next section. So they're all right here. They're going to be right here. So you guys can see them. These are exactly the same as what I have right here. I have these with x's, the thetas on your paper. That's the same thing. Use whatever variable you like. So let's go ahead and let's hop into today's lesson. So when I reference angles, it's going to be these angles right here. How do I know I'm talking about a double angle? That's going to be when you have this 2x, or 2 theta. So it's sine, cosine, or tangent of a 2 theta or a 2x, whatever the variable might be. Also note on cosine, you have 3 different options. That's the only one you have 3 different options, and it doesn't matter which one you choose. If you're looking for the double angle of cosine and you know sine, then I would pick this one. If you know the cosine value, I would pick this one. If you know both of them, then maybe you pick the cosine squared minus sine squared. So there's options. So let's go ahead and let's start with this first problem. This first one says analyze the derivation of the tangent double angle identity. So tangent of 2x. Well, 2x, isn't that the same thing as x plus x? Yeah. If I add x plus x, it's just 2x. And this should look really familiar to you guys because this is just going to be a sum formula. If you remember, the sum of a tangent is going to be tangent. This is alpha, you can use x or whatever, tangent of beta, 1 minus tangent alpha, tangent beta, and that's all they're doing here. But instead of alpha and beta, they have x and x, and they just plugged it in. So this right here, so from here to here, this is just an addition, right? We just are breaking them apart, we're just adding. From here to here, though, is going to be my tangent sum identity. Well, then if I look here, a tangent plus a tangent is going to be 2 tangent, right? So all we needed to do here was simplify. And so those are going to be each of the steps. So I didn't write them in their box, but my step 1 was just an addition. My step 2 was the sum, and my step 3 was simplify. And it's a drop-down menu, so it's nice because you'll know exactly how it's worded. All right, so how do I use these formulas? Okay, so I could actually solve this as is, but that's not what they want us to do. So they want us to use our formulas to evaluate this. And I also want to point out that when I see sine squared of 165, this is just a little side note, that if I have sine squared of 165 degrees, this is the same thing as saying sine of 165 degrees squared. Those are equivalent. So it's saying when it's sine squared, that it's next to that square, the sine is next to the, the squared is next to the sine, it's saying it's the whole thing squared. Different than saying sine of 165 squared is squaring that 165. So that's why they put the square next to the sign when they want the whole quantity. So that kind of gets confusing sometimes. I wanted to make sure to point that out to you guys. All right, so this is some value. I'm going to go ahead and I'm going to rewrite this as 1 minus 2 sine squared of x. Because visually, sometimes it's easier for you guys to look at it without this number in when we're trying to correlate to the formulas. So I'm basically saying that that x is equal to 165. The reason why I wrote it like this is because if I look up here, if I look up here, I can match that equation to this right here, right? It was 1 minus 2 sine squared of x, which is equal to a cosine of 2x. So this piece right here is equal to cosine of 2x. Well, what does that mean? Well, that means that this is going to equal cosine of 2, and we said x is 165, so times by 165. Which means that that value is just going to be equal to cosine of 330 degrees. And I go to my unit circle, and I look at 330 degrees, 330, my cosine value is the square root of 2 over 2. Square root of 2 over 2. So this is just going to be equal to, sorry, I said square root of 2 over 2, square root of 3 over 2, square root of 3 over 2. So this is going to be just the square root of 3 over 2. Could I have found sine of 165? Yes. Then I would have had to square it. Then I would have had to multiply it by 2. And then I would have had to take that value and subtract it from 1. That's a lot of work. Or I could have just done this, which was way easier to do. All right, let's look at another one. So this is when we're given our unit circles or given values on it, whether it's in degrees or radians. Very similar to the last few sections, we're not always given values in degrees or radians. Sometimes they look like this, and they're given to us as a fraction. Sine of x is equal to some value, and we're given quadrants. This is going to help me find my quadrants. That's when we need to use the triangles. That's when we need to use the triangles. So I'm asked to find sine of 2x. And I know from my formulas on the front side of my paper that sine of 2x is equal to 2 sine of x cosine of x. Well, perfect. I already know what sine of x is. So be careful, because it's not one, even though I know sine of x is 2/5, this isn't saying it's 2 times 2/5 there. That's not the same thing. It's not equivalent. So I know sine of x is 2/5. So I know that this sine of x right here is 2/5. I know I still have my 2 out in front here, but I don't know what this cosine of x is. Man, that's why I need to use my triangles. So I go ahead over here and I know that I have my sine of x is equal to 2/5. And I also have this piece right here that tells me tangent of x is greater than 0. In other words, tangent is positive. Now, the reason that they tell me this is because this helps me determine what quadrant I'm in. All students take calculus. So they're all positive here. Sine is positive, tangent is positive, and cosine is positive. So here's what I know. I know that my sine is positive because it was given to me positive. So I know then that I can't be in quadrant 3 or 4, because if I'm in one of these two quadrants, then sine would be negative. I also know that my tangent of x has to be positive because it says it's greater than 0. So if I look here, I already know I can't be one of these two. And if I'm in quadrant 2, tangent's not positive. So I could cross that one out. That means that I have to be working in quadrant 1. So they're all going to be positive, which is great because when I go find my cosine of x, I know it has to be a positive value. Now I look at my triangle. This is my opposite over my hypotenuse. So my opposite side is 2, my hypotenuse is 5, and I would use my Pythagorean theorem. 2 squared plus my adjacent side squared is equal to 5 squared. So we need to figure out what my adjacent side is. So 4 plus a squared is equal to 25. A squared is equal to 21. So a is going to be the square root of 21. Cosine then is adjacent over my hypotenuse, so it's a square root of 21 all over 5. So for this piece right here, I could go ahead and I could plug in my square root of 21 all over 5. I multiply everything through. If you want, if it helps you guys, remember the same thing as 2 over 1. And so it'd be 2 times square root of 21, which is going to give me 4 square root of 21. And this is 5 times 5, which is going to give me, you could do 1 times 5 times 5, which is going to give me my 25. So here's my answer right here. Done. So this one was a little bit different than what we've seen lately. A lot of them that we've seen, it says you're in quadrant 3 or you're in quadrant 2, whatever it is. This one, you kind of had to figure it out a little bit. So be cautious about that. And just look at one piece at a time. And I usually just scribble out, okay, it can't be these ones, so scribble it out. Okay, I also can't be this one, and so what's left? All right. So my next one. Before I get started on this one, I want to recall a couple things. So prior knowledge. I just want to go over your Pythagorean identities for your trig. So we know a squared plus b squared is equal to c squared. That's a Pythagorean identity, yes. But what about for trig? So what were those values? So just as a little bit of a recall, I have sine squared theta plus cosine squared theta is equal to 1, is one of your Pythagorean identities. I have 1 plus tangent squared theta is equal to secant squared theta. And my last one was 1 plus cotangent squared theta is equal to cosecant squared theta. These are the 3 Pythagorean identities. So hopefully you guys, those look kind of familiar to you guys from the end of last semester. So they come up still, and so that's why I kind of wanted to give you guys a little bit of a refresher of what they are. This one right here is probably the most common one that we use. This is our most common one. Doesn't mean that you may not see these, but this is one that I feel like is always showing up when we do use them. Okay, so let's go ahead and let's hop into this first problem. It says the following steps show how the right side of, and here's your equation, 1 plus sine of 2x is equal to sine of x plus cosine of x, that whole quantity squared, can be rewritten to show it as an identity. Okay, so what are the correct justifications listed in the proper order? So they kind of give you your justifications of what you're going to use already. So distributive property, Pythagorean identity, double angle identities, they have them here, but what is the order of things going on? So I look and go, okay, well, how did they go from here to here? And this is kind of confusing for you guys when you guys look at this, like how did they get this whole thing? Well, this quantity squared, it's saying that you're taking your sine of x plus cosine of x, and you're multiplying it by a sine of x plus cosine of x. So then you would distribute it through. And when you distribute it through, you get a sine squared of x plus a sine of x, cosine of x, plus another then sine of x, cosine of x, and then you get your cosine squared of x. So this is where the 2 comes from. So what did we do here? We just distributed. We just did distributed. Let me write it in a color. This was just the distributive property. Okay, well then how did I go from here to here? How did I go from here to here? What was going on? What changed? Well, I notice I still have my cosine, my 2 sine of x, cosine of x, but these 2 pieces are gone. That's because a sine squared of x plus a cosine squared of x, sine squared of x plus cosine squared of x is equal to 1. That's just equal to this value of 1. That's because that's a Pythagorean identity. And then if I look at my formulas for my double angles, look here, 2 sine of x cosine of x, 2 sine of x cosine of x is going to be sine of 2x. So this is just equal to, so from here to here, this piece was just going to be my double angle identity. So look, I did distributed, Pythagorean, and double angle. So I'm going to go ahead and mark the one that puts it in that order. Done. So again, don't overthink these, take them piece by piece. Stop, Google. I don't know why Google started talking. All right, and our last one. Stop. Go figure, right? Okay, so my last one, very last one. This is probably the trickiest, and I'll make sure to point out something important. But remember, we're over the interval from 0 to 2 pi, so just values that are going to be on our regular unit circle. And it says to write all the solutions for these. It says to check all that apply. All right, well, where do I begin? So might have to try to get things in the same terms, or let's get rid of this double angle because I can't solve it. When I have a sine and a cosine like this, I need to do something here. So I'm going to go ahead and I'm going to rewrite this using my double angle formula. And that tells me that sine of 2x is the same thing as 2 sine of x cosine of x minus 2 cosine of x. All right, here's going to be where your number one mistake is. Some of you guys are going to want to cancel off cosine of x from both sides. And that looks great. The problem is you are erasing answers. You cannot do that for this. So be careful because that's going to be the number one mistake and you're not going to get all of the answers. So you cannot just simplify it like that. You want to set it equal to 0. Because otherwise you're going to be canceling off your cosine of x value. So let's see what happens when I do this. So I'm going to go ahead, I'm going to subtract 2 cosine of x from both sides. And when I do that, I get 2 sine of x minus, cosine of x minus 2 cosine of x is equal to 0. And if I notice, each of these are their own terms, right? That's one term, two terms. They both have in common a 2, and they both have a cosine of x. So I can factor out 2 cosine of x times my sine of x. Now, when I factor this out, it doesn't just become nothing there. It becomes minus that value of 1, right? Minus 1 is equal to 0. Because if I distributed this through, I need to end up with this value back. I need to end up with what I have up here. Now, if I had something like 2x times x plus 1 is equal to 0, remember, we would set each of the pieces equal to 0. That's what our zero product property tells us, right? Same idea happens here. So I would take each one of these, my 2 cosine of x, set it equal to 0, and my sine of x minus 1 is equal to 0. So I would set each piece equal to 0. Again, that's my zero product property. Just like if I didn't have the sine or cosine values, it's the same idea. I could go ahead and divide both sides by 2 here. So I have cosine of x is equal to 0. So I want to know, when is cosine 0? I go to my unit circle, when is cosine 0? It's 0 here at pi over 2, and it's 0 here at 3 pi over 2. Remember, I'm using radians because it told me 0 to 2 pi. So that's how I know degrees versus radians. So I have x can equal pi over 2, or my 3 pi over 2. But I also have this piece right here where I'm going to add 1 to both sides, and I have sine of x is equal to 1. So when is my sine value a value of 1? When is sine 1? So that's talking about my y value. So I look for my y value to be 1, and it only happens here at pi over 2, at pi over 2. So in this case, then x is equal to pi over 2, which look, these two happen to be the same. They're the same. That's okay. You just need to write in your final answer once. But then I look up here and it says, okay, check all that apply. Well, it's my pi over 2 and my 3 pi over 2. And that was it. Those are all the solutions. And I'm done. So if I plugged either one of these values in up here, the two sides would be equal to each other. They would be equivalent. And you can always plug them in your calculator to check if you'd like. So again, this is going to be just kind of on the instruction today. It's summarizing things that you're going to be doing. Tomorrow we'll go over the assignment. Yes, I was like, what day of the week is today? So yes, tomorrow we'll do assignment, and then on Monday we'll go ahead and do the quiz. If you guys have any questions, please feel free to reach out to me. I'm here for any help that you guys need. Remind, email, send me a picture of a problem you're stuck on. Just let me know. Otherwise, you guys have a wonderful day, and I will see you guys tomorrow. Take care. Thank you.
Have a good day.
Thank you. You too. Bye.
Bye.